Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 3 video on the chapter of exponents where I will discuss about numbers in standard form and how to express very large and very small numbers, that is decimal numbers, in standard form using the concept of exponents or the form of exponents. So this will be a hybrid mode of video where I will discuss the theory as well as to apply the concepts. I will solve the exercise problems of exercise 2B from the textbook of author RS Aggarwal. So this video is part of the playlist CBSE Mathematics for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my rough notes prepared on today's topic of this video on the left hand side, and on the right hand side I will solve any concepts or discuss the concepts and solve the problems of exercise 2B. Okay, so this video we will discuss about numbers in standard form. So any number, whether usually we will discuss about expressing the standard form of very large and very small numbers. Now a very large and small number, so while I am speaking or discussing, you can follow the notes, take screenshot of the notes for your future reference. So a large or small decimal number, say n, is said to be in standard form if expressed as below. So if n is expressed as x multiplied by 10 to the power 5, so this 10 to the power y is an exponential form. So a number in standard form is expressed using the concept of exponents. So any number when a large number or a small number is expressed as x multiplied by 10 to the power y, where x is a decimal number that is greater than or equal to 1 and less than 10. This is super important. X, the number, it's a decimal number, like it could have a decimal point, or it could be an integer, or even a natural number or a decimal number. But that decimal number has to be greater than or equal to 1 and less than 10. And y is a non-zero integer. Y is not equal to 0, but it is an integer. It can be positive integer or negative integer. So as an example, you can see, so a number in standard form could be like this. Let's say it could be 2 multiplied by 10 to the power 6, or it could be 2.5 multiplied by 10 to the power minus 12. So the power y can be a positive or negative integer, but x has to be a decimal number greater than or equal to 1 and less than 10. Now this is not the last one is not a number in standard form. This is not in a standard form, because x is 11, which is greater than 10, or even minus 2 multiplied by 10 to the power 3. This is also not in standard form, because x is less than 1. X has to be greater than or equal to 1 and less than 10. Now as you can realize that this standard form is only used for representing positive numbers. It could be very small, or it could be a very large number or a small number, but it is a positive number. Okay. So this is a number in standard form. Now how do we express a very large decimal number in standard form? So let's say if you are given a very large number in standard form, so I will discuss the steps. There are 4 steps involved in expressing a very large number in the standard form. So while I am discussing the concept, let's discuss the concept with an example. Let's say the number of the very large number, let's say n, the very large number is given to be 965400000. So let's say this is the number, the very large number. How do we express this large number? This form is known as the usual form, and the one with x multiplied by 10 to the power y, that form is known as the standard form. Also, sometimes it is known as scientific notation or scientific form. Now, n equals to 9654000. This is the usual form. So, so you will be asked to express a number in usual form in the standard form. So, how do we convert this very large number in the standard form? So, step 1 says put a decimal point after the leftmost digit of the number. Okay. So, after step 1, the leftmost digit in this number is 9. So, I will put a decimal point after 9. So, after step 1, I get 9.654 and 5 zeros. Okay. Okay, fine. 5 zeros. Then step 2 says count the number of digits to the right of the decimal point, let it be y. So after we get this, after step 1, we have to count the number of digits in the number after the decimal point. So we have 654 and 5 zeros, that is we have 8 digits to the right of the decimal point. So after step 2, we get y equals to 8. Okay. Step 3 says consider the number obtained in step 1. So this number we obtained in step 1. Consider the number obtained in step 1 as x after removing trailing zeros. So we have some trailing zeros. We have 5 trailing zeros. Remove the 5 trailing zeros, and whatever number is left, that is the number we get as x after step 3. So this let me write it correctly. So after in step 2, what do we get? In step 2 we got y equals to 8. Now in step 3 we got x equals to, I will consider the number, this number after step 1, but I will ignore all the trailing zeros. These are the trailing zeros. So it becomes 9.654. So I got x and I got y, and the last step 4, it says the number in standard form will be, so I got the final standard form as x into 10 to the power y, that is 9.654 multiplied by 10 to the power 8. So so this is the final standard form of the given number, that is 9654 and 5 zeros. So what are the steps? First, you put a decimal point after the leftmost digit of the number. You are given the very large number, in this case 9654 and then 5 zeros. The leftmost digit is 9. After that, put a decimal point. So I get 9.654 and 5 zeros. Okay, step 2. After I get this number after step 1, I will count the number of digits to the right of the decimal point. All the digits to the right of the decimal point. I can see the digits are 654 and 5 zeros. So 8 digits. So I get y equals to 8 after step 2. Now what is step 3? Step 3, I will have to get the x, the number x. How? From step 1, I got the number 9.654 and 5 zeros. From this, I will consider this number, but I will ignore all the trailing zeros. So I got 9.654 as x. So I have x, I have y. So the standard form will be x multiplied by y to the power 10 to the power y, that is 9.654 multiplied by 10 to the power 8. So this is how we express a very large number in the standard form. Now let's discuss how do we express a very small number. How do we express a very small number in the standard form? Now a very small number will be of the form at the decimal form, like after decimal point there will be no, definitely there will be no whole part, since it's a very small number, so it will be no whole part, but after the decimal point there will be a lot of zeros and then some digits. Anyway, so those are the numbers which we need to express in standard form. So what is step 1? So let's take an example. Let's say the number is, very small number is 0.0000231. Okay, so I have this very small number. How do I express it as a standard form? So step 1, count the number of digits to the right of the decimal point up to the first non-zero digit, let it be y. So you have a very small number, definitely it will be a decimal number. You have a decimal point. Count the number of digits up to the first non-zero digits. In this example, it is 2. So how many digits are there up to 2 to the right hand side of the decimal point? 1, 2, 3, 4, 5. So after step 1, I get y equals to 5. Y equals to 5 because these are the digits, all the digits to the right of the decimal point up to the first non-zero digit. How many digits are there? 0, 0, 0, 4 zeros and 2, so 5. So we have y is equal to 5. So this was step number 1. Step number 2. In step 2, what do we do? Consider the number as a whole number, ignoring the decimal point. Now you have the number, decimal number, original decimal number. Now consider it as a whole number. Consider it as a whole number, ignoring the decimal point. Whole number, just ignoring the decimal point, and so it becomes 2, 3, 1. 2, 3, 1. Because in a whole number, any zeros to the extreme left does not matter, is meaningless. Okay, so I have this whole number 231. Consider the number as a whole number, ignoring the decimal point. Then it is saying put the decimal point after leftmost digit. Okay, so I will put a decimal point to the left after leftmost digit, that is after 2. I will put 2.3 and I got 2.31, and ignore all trailing zeros. In this example, there are no zeros after 1, so there are no trailing zeros. So the number becomes 2.31. This is x. So after step 2, I got x equal to 2.31. So what was step 2? You have the original number, the given very small number. You consider the number as a whole number by ignoring the decimal point. So if I do that, the number will be some beginning zeros and 231. And we know that in a whole number, any zeros to the extreme left does not make any sense. So we ignore them. So the whole number becomes 231. Now you put a decimal point after the leftmost digit. In this case, it is 2. So put a decimal point after 2. So we got 2.31. This is x. Now as a final step, the standard form will be x multiplied by 10 to the power minus y. Please keep this thing in mind. It is not 10 to the power y, 10 to the power minus y. So this becomes 2.31 multiplied by 10 to the power minus 5. Okay, so this is how we express a very small number in the standard form. So this is all regarding the numbers in standard form and how do we express very large and very small numbers in the standard form. Now let's solve the problem of uh, problems of exercise 2b from the textbook of author RS Aggarwal. So if you can take a screenshot of the notes. I will quickly scroll over the notes. You can take screenshot for your future reference. Okay, now let me bring up the problems of exercise 2b. Let me see if you can see it. Okay. Okay. So let's solve the problems of exercise 2b. Maybe you cannot see the whole question, but no problem. I will read it. So problem number 1 has 6 parts. It says write each of the following numbers in standard form. Okay, so we some numbers are given. Some might be very large number and some might be very small numbers. We have to convert each of them to the standard form. The first one is 57.36. Now from the given number you can easily understand whether it's a large number or a small number. Now 57.36, please do not say this is not a very small number. You can consider it as a large number. So I will apply the steps, the logic of converting a large number to the in standard form. So I have this. Write each of the following numbers in standard form. Now what was now if I in my notes, the steps I have discussed for expressing large number, there was no decimal point. I assume that there was no decimal point. Now for this kind of problem like this one, you know that the standard form is x multiplied by 10 to the power y, where x is a number greater than or equal to 1 and less than 10, and y is a y not equals to 0. Now I am not sure whether we have studied set or not. Y is a all the integers. There is a there is a concept of set, and all the integers is considered as a set, which is represented by the letter z. And the fact that y is an integer not equals to 0, that y is an integer, we denote it as y belongs to the set z. This means z is a letter or set of all integers. But if we just say y belongs to, and this e, this is epsilon, e, this symbol is known as belongs to. Y belongs to z means y is an integer, but y should not be a 0. So I have written y not equals to 0. So this is the standard form. Now from this, this is a very trivial example. You can clearly say that you can convert, you can put the decimal point, you can put the shift the decimal point to the left hand side. So I can at the x I can write it as 5.73x. So I have shifted the decimal point to the left hand side. Now to adjust I have to multiply it with 10. I have to multiply it with 10. So this is the number in standard form. This is the number in standard form. So some examples, it will be very trivial. You can do it manually. You did not follow the steps or algorithms that I have discussed. For the okay, so this part 2, we have 3, 5 and 5 zeros. Now this is a good number, a large number, where you can apply my logic or steps of converting it or expressing it as a standard form. So what are the steps? You put after the first step, you put the decimal point after the leftmost digit. So this is 3.5 and 5 zeros. Then I have to find out y. What will be y? Y will be all the digits, number of digits to the right of the decimal point. And how many digits do we have? 5 and 5 zeros, that is 6. We have to find y. What will be y? Or number of digits to the right of the decimal point. So we have 5 and 5 zeros, that is the digit 5, and there are 5 more zeros, so which makes y equals to 6. Now step 3, we have to find x. What is x? X will be equal to, now x will be equal to, you consider the number obtained after step 1, but you ignore all the trailing zeros. So 3.5. And the last final step, we get the standard form as x into 10 to the power y. This is equal to 3.5 10 to the power 6. Now while solving the problem in your exam or school, I hope you will not do it like this. This is just for explanation, so that you understand what is happening, what you are exactly doing, or what is happening. So let me quickly check if this is correct or not. So whenever you solve this kind of problem and you have found the number in standard form, always recheck by multiplying the 10 to the power, for this problem, multiply 3.5 into 10 to the power 6 and see that indeed if you are getting the original number. So I can see if I multiply 10 to the power 6 with 3.5, I will get 35 and 5 zeros. Okay, fine. So this is the number in standard form. Okay, this was part 2. Part 3. Part 3 is 27. So n is equal to, let me not write n, maybe it will confuse you. 273 and 3 zeros. Okay. So after the first step, what will I do? I will put a decimal point to the left after the leftmost digit. So 2.73000. Now I need to find. Now the circle 1 and 2 means after the steps. After step 2, I need to find what is y. Y will be the number of digits to the right of the decimal point. So I can see there are 5 digits. Okay. After step 3, I need to find x. What will be x? After step 1, I get the number as 2.73000. From this number, I will ignore all the trailing zeros. Trailing zeros means all the zeros to the rightmost zeros. That is in the decimal part. The decimal part is 0.73000. In the decimal part, ignore all the rightmost zeros. So this becomes x as 2.73. So now the final result after step 4, you get x into 10 to the power y is equal to 2.73 multiplied by 10 to the power 5. So this is the number. So this is the standard form of the given number 273000. Okay. Part 4. Part 4 is, the number is 168, and how many zeros? 1 2 3 6 zeros. 1 2 3 4 5 6 zeros. Okay. So after step 1, I will put the decimal point after the leftmost digit. So it becomes 1.68 and 6 zeros. Okay. Then I will find after step 2 what is y. That is the number of digits to the right of the decimal point in the number after step 1. So I can see y after the decimal point. The number of digits are, we have the digits 6 and 6 8 and then 6 zeros. So 8. Now after this, we have to find After the step 3, we will find x. What is x? X is after step 1, we get the number 1.68 and 6 zeros. So from this number, I will ignore all the trailing zeros. So this becomes 1.68. So the final step, I will get the standard form as x multiplied by y to the power 10. This is 1.68 multiplied by 10 to the power 8. This is the standard form. Okay, let's do part. So while I am solving the problem, you can pause the video and take screenshot of the solution for your future reference. So I am quickly scrolling down of the solution of all the problems done so far, so that you can take a screenshot. Okay, let's do part 5. Part 5, the number is really big. 4, 6, 3, and how many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 zeros. Okay. So after step 1, I will put a decimal point after the leftmost digit. So it becomes 4.63 and 10 zeros. 10 zeros. Okay. Now I will count, I will find y, which is the number of digits to the right of the decimal point. So we have the digits 6 and 3 and then 10 zeros. So it means y equal to 12. Now after step 3, I will find x. What is x? The number after step 1 was 4.63 and then after 63, 10 zeros. So I will ignore all the trailing zeros. So all the 10 zeros I will ignore. So it becomes 4.63. So the final step is I get the standard form, which is x multiplied by 10 to the power 4, 10 to the power y, which is 4.63 into 10 to the power 12. So this is the standard form. Okay, there is 6. 6 is 345 multiplied by 10 to the power 5. Now for solving this kind of problem, in which you already have the 10 to the power term factor, you just need to manipulate it a little bit and you can easily get the standard form. So what will I do? So definitely I have to somehow make the 345 as 3.45. Okay, so what can I do? What do I have to do to make 345 as 3.45? I have to definitely divide 345 by 100. If I divide 345 by 100, then only I will get a decimal point 3.45. But I also have to adjust it by multiplying with 100. So it becomes this. I want to convert 345 as 3.45 because the x factor, has to be a number greater than or equals to 1 and less than 10. So 3.45 could be that number x. So I want to make 3.45. So I have to divide by 100. So if I am dividing by 100, I cannot change the original number. So to keep the original number unchanged, when I am dividing it by 100, I also have to multiply it with 100. Okay. So this now becomes 3.45, and this 100 and 10 to the power 5, as you know, 100 is 10 square and we have 10 to the power 5. So this becomes 3.45. 10 square into 10 to the power 5 from the laws of exponents, you can say this is 10 to the power 7. So this is the standard form. Okay, so that was problem number 1. Let's do problem number 2. These are all very small numbers. No. Write each of the following numbers in usual form. Okay, so we are given all the numbers given are in standard form. We have to write it in usual form. Even though I did not discuss this part, how to convert a number in standard form to usual form, but the concept is very straightforward and based on common sense. So let's say part 1 is 3.74 multiplied by 10 to the power 5. So now this the concept you will apply is from the concept of decimal numbers, that is when you multiply a decimal numbers with a power of 10. You have possibly learned this in class 7. In class 7 you have learned how to multiply decimal numbers, and one such case was to multiply a decimal with a power of 10. So what do? You have 10 to the power 5. 10 to the power 5. So when I multiply 3.74 with 10 to the power 5, I have to shift the decimal point 5 places. So let's say this is the number. I have to shift the number. I have to shift the decimal point. Let's say, so I have 3.74. I have to shift the decimal point 5 places to the right hand side. So when I am doing that, how does the shifting happens? 1 shift, 2 shift, 3, 4, 5. And by arrowhead I mean the decimal point, the final decimal point will be here. And in between, if you see there are empty spaces, you just put 0. 1, 2, 3. So this becomes 374,000, and this decimal you can ignore. You can ignore this decimal. So this is equal to 3, 7, 4 and 3 zeros. So this is how, if you have little bit of problem in doing this kind of multiplication, that is multiplying a decimal number with a power of 10, you can do this way visually. Another way is that you have 3.74 multiplied by 10 to the power 5. Now this is equal to, you convert 3.74 in the fraction form, that is you divide by some power of 10. And what will be the power of 10? What will be the power? The number of digits to the right hand side of the decimal point. In 3.74 I have 2 digits to the right hand side of the decimal point. So I will write it as 374 divided by 10 to the power 2. Why 2? There are 2 digits to the right hand side of the decimal point. So this becomes 374 divided by 10 square, and I have 10 to the power 5. So this is equal to 374. If I group together the powers of 10, I have this. Now from this, using the laws of exponents, I can say that 10 to the power 5 divided by 10 square is nothing but 10 to the power 5 minus 2. This is equal to 374 multiplied by 10 to the power cube. This is equal to 374,000. Mathematically, using the laws of exponents, you can try this latter method. That is, you convert the decimal number in the fraction form. So in the fraction, the denominator will be some power of 10, and that power will be the number of digits in the decimal number to the right hand side of the decimal point. And then you adjust the powers of 10, and finally you do the product of the whole number. In the final stage, we multiplied a power of 10 with the whole number. That you should be able to do. Okay, so this was part 1. Part 2 is 6.912. So I think mathematically, while you are solving it, I think it's better you apply the second method instead of the visual ones. Okay, so I have this. I have to convert it into the usual form. So I know 6.912 will be in fraction form 6.912 divided by 10 cube. Why cube? Because there are 3 digits after the decimal point. And I have the 10 to the power 8. So this is equal to 6912 multiplied by 10 to the power 8 divided by 10 cube. This is equal to 6912 multiplied by 10 to the power 5, and this is equal to 6912, and I will add 5 zeros. So this is the number in usual form. Okay, let's see part 3. Part 3 is 4.1253 multiplied by 10 to the power 7. Okay, so I will convert the x part, that is the 4.1253 in the fraction form, where the denominator will be power of 10. So I have 4 digits after the decimal point. So this will be 41253 divided by 10 to the power 4, and I have the 10 to the power 7. So this becomes 41253 multiplied by 10 to the power 7 divided by 10 to the power 4. This is equal to 41253 multiplied by 10 to the power 7 minus 4. This is equal to 41253 multiplied by 10 cube. This is equal to 41253 and 3 zeros. So this is the number in usual form. Okay, part 4. Now these are all same. I hope you have understood the concept, and even though it is not really necessary to solve this, but still for the sake of completeness I am solving all the problems. This is 2.5 multiplied by 10 to the power 4. So this is equal to 25 by 10 multiplied by 10 to the power 4. Now I will skip a few steps. I hope you will understand. This is 10 to the power 3. This is equal to 25000. 25,000 is the number in usual form. My machine is running very slow. Part 5. 5.17 multiplied by 10 to the power 6. This is equal to 517 divided by 10 square multiplied by 10 to the power 6. This is equal to 517 multiplied by 10 to the power 4. This is equal to 51740. Okay, part 6. Part 6. What is part 6? Okay, 1.679 multiplied by 10 to the power 9. So this is equal to 1679 divided by 10 to the power 3 multiplied by 10 to the power 9. This is equal to 1679 multiplied by 10 to the power 6. This is equal to 1679 and 6 zeros. Okay, so this was end of problem number 2. Now problem number 3 is a kind of what problem. It says the height of we have part. Okay, so first part is the height of Mount Everest is given to be 8848 meter. Write it in standard form. Okay, so basically we have to write 8848 in standard form. Now this is not a very big number. you can manually do it. Now, if you want to follow the algorithms or steps I mentioned in the discussion while discussing how to express a large number in standard form, what you will do is uh, first you will put the decimal point after the leftmost digit, that is 8. We have 8.848. Then you will find y, that is the number of digits after the to the right hand side of the decimal point. We have 3, and then you will find x, which is the number obtained after step 1, but ignoring all the rightmost zeros. So this becomes 8.848, and the last step is the standard form will be x into 10 to the power y. This is 8.848 multiplied by 10 to the power 3. So this is the height of the, we can use the unit meter. This is the height of the Mount Everest in the standard form. Part 2. Okay. Part 2. The speed of light is 3 and how many zeros? 1, 2, 3, 4, 5, 6, 7, 8. Okay. It is given that the speed of the light is 1, 3 and then 8 zeros. This is the speed of light. 1, 2, 3, 4, 5, 6, 7. How many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9. God. Okay. 1, 2, 3, 4, 5, 6, 7, 8. How many zeros? 1, 2, 3, 4. Okay. So the speed of the light is given as this meter per second. Now we have to express it in standard form. Okay. So as a first step, put a decimal point after the leftmost digit. That is, we have 3 point and obviously 8 zeros. Then you count the step 2. You count the y. You find the value of y, which is the number of digits to the right of the decimal point, and definitely there are 8 zeros, so y will be 8. Now we will obtain x as the number obtained after step 1, but ignore all the trailing zeros. So we have 3. So the standard form will be x multiplied by 10 to the power y, that is 3 multiplied by 10 to the power 8 meter per second. So this is the speed of light in the standard form. Okay. Part 3. It is said that the distance from the earth to the sun is 1496, and how many zero? 1, 2, 3, 4 and 8 zeros. Okay. This is the distance of the earth from the sun, this much meter. We have to express this distance in standard form. Okay, fine. So put the decimal point, step 1, put the decimal point after the leftmost digit, that is 1 point. We have the number 1.496 and then 8 zeros. Okay. Now we will find after step 2 y. What is y? Y is the number of digits to the right hand side of the decimal point, and we have 496, 3 digits, and then after that we have 8 zeros. So this is 11. Okay. After step 3 we will find x. X will be equal to the number obtained after step 1, but we will ignore all the trailing zeros. So it becomes 1.496. And finally, after step 4, the standard form will be x multiplied by 10 to the power y, which is equal to 1.496 multiplied by 10 to the power 11 meter. So this is the distance of the earth from the sun in standard form. Okay. So this was problem number 3. Problem number 4 says mass of earth is, a number is given, the mass of the earth is given in standard form 5.97 multiplied by 10 to the power 24 kg, and mass of moon is also given in standard form in kg. What is the total mass of the two? Okay, so I am denoting mass of earth as m and subscript with e. Mass of earth is given to be 5.97 multiplied by 10 to the power 24, and mass of sun is given to be, sorry, this is kg, okay, this is mass of earth, and the mass of moon, okay, so mm. Mass of moon is given to be 7.35 multiplied by 10 to the power 22 kg. We have to find the total mass in standard form. So we have to find what is the total mass. Obviously we have to find the total mass in standard form. Some hints are given. I am not looking at the hints at all. Total mass is me plus m, which is equal to 5.97 plus 10 to the power 24 plus 7.35 multiplied by 10 to the power 22. Now how do you do this kind of additions of two standard numbers in standard form? That is, we have addition of two numbers where each number has a factor of power of 10. Now you need to consider some power of 10 as the common factor, which will be the common factor as power of 10 will be the power of 10 which is the minimum between the two powers. I have power of 24, that is 10 to the power 24, and 10 to the power 22. I will take 10 to the power 22 as the common factor. So how will I do that? I know that 5.97 this is multiplied by, I can write it as 10 to the power 22 multiplied by 10 square. I can write this 10 to the power 24. I can write it as 10 to the power 22 and 10 to the power 2 from the laws of exponent. Using the laws of exponent, we know that x to the power m, using the fact that x to the power m multiplied by x to the power n is nothing but x to the power m plus n. So we have this. Now, so now I will multiply 5.97 with the 10 square, and I have 10 to the power 22, and I have plus 7.35 multiplied by 10 to the power 22. So this is equal to, now if I multiply 5.97 multiplied by 10 square, it will be 597. I have 597 into 10 to the power 22 plus 7.35 multiplied by 10 to the power 22. Now I can, using the distributive law of multiplication over addition, I can say this is equal to 597 plus 7.35, this addition multiplied by 10 to the power 22, using the law of distributive law of multiplication over addition. Okay. Now let's simplify the value inside the bracket. This will be 0.35 and then I will have 14, 10 and 604.35. I have 10 to the power 22. So this is the total mass, which is not in standard form. We have to find the total mass in standard form. So now I have to convert this in standard form. Now this is not in standard form because the x is not greater than or equals to 1 and less than 10. It is a huge number, 604.35. So what will I do is, I will have to convert 604.35. So I have to bring the decimal point after 6. If I want to bring the decimal point, right now the number is 604.35, but I need the decimal point after 6. So I have to shift the decimal point 2 places to the left hand side. That is, I am dividing by 100. If I do this, if I write this, I have basically divided by 100. So I have to also multiply with 100, that is 10 square. So this is now equal to 6.0435 multiplied by 10 to the power 24. This is the total mass in standard form. Okay. I hope you understood the concept. From the two given mass, I can see I have taken 10 to the power 22 as a common factor. The common factor will be the least power of 10. In this problem, the powers of 10 are 10 to the power 24 and 10 to the power 22. 22 is less. So I will take 10 to the power 22 as common factor. In doing so, I will split 10 to the power 24 as 10 to the power 22 multiplied by 10 square. And then I have merged 5.97 multiplied by 10 to the 10 square. Merge that, and I got 597. So now I got 597 multiplied by 10 to the power 22 plus 7.35 multiplied by 10 to the power 22. So I can see I can apply the law of distributive law of multiplication or addition, and I can rewrite it as this. So using the concept of distributive law of multiplication over addition, that is, A multiplied by B plus C is equal to A multiplied by B plus A multiplied by C. Now I added 597 plus 7.35. It came out to be 604.35 multiplied by 10 to the power 22. So I got this number, which is not in standard form because the x over here is greater than 10. I have to make 604.35 in such a form that it is 6.0435. So I have to divide it by 100. Now when I am dividing by 100, to keep the number unchanged, I have to multiply with 100. So I got 6.0435 multiplied by 10 to the power 22 multiplied by 100, that is 10 square. So 10 to the power 22 and 10 to the power square, using the laws of exponent, it is 10 to the power 24. So finally we got 6.0435 multiplied by 10 to the power 24, this much kg is the total mass of the earth and moon. Okay, let's do problem number 5. There are 6 parts. Okay, write each of the following numbers in standard form. Okay, so these are very small numbers. 0.0006. I have to convert in standard form. So what was the logic steps to express a very small number in standard form? I will count, first of all, after step 1, I will count the number of digits to the right of the decimal point up to the first non-zero digit. In this example, it is 6. How many digits are there? So the digits up to the first non-zero digit is, these are the digits to the right hand side of the decimal point. So y is, how many such digits are there? 4. So y is 4. Okay. Now after step 2, I will consider the given number as a whole number, ignoring the decimal point, which becomes 6. And in that number 6, I will put a decimal point after the leftmost digit. So it becomes 6.0. We can say 6.0. X we got 6.0, And then the final step is the standard form will be x multiplied by 10 to the power minus y. Please do not make mistake. It is 10 to the power minus y, not 10 to the power y. So this is 6.0 multiplied by 10 to the power minus 4. We can also write it as 6 multiplied by 10 to the power minus 4. So this is the number in standard form of the given very small number. Okay, so let's do part number 2. Part 2 is 0 point of how many zeros are there? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. 6 zeros and 83. After decimal point there are 6 zeros and then 83. Okay. First step, after first step I will find y. Y is what? All the number of digits to the right hand side of the decimal point up to the first non-zero digit. These are those digits. The number of digits to the right hand side of the decimal point up to the first non-zero digit. So these are the digits are the, how many digits was there after 0? After decimal point 1, 2, 3, 4, 5, 6. Okay. So we have 6 zeros and then 8. So that is 7. Y is 7. Because after decimal point we have 6 zeros and then 8. So the number of digits to the right hand side of the decimal point up to the first non-zero digit will be 7. Then after step 2, I will consider the given number as a whole number ignoring the decimal point, and that becomes 83. But I will put a decimal point after the leftmost digit. So x becomes equals to 8.3. So after the final step, the standard form will be x multiplied by 10 to the power minus y. This is equal to 8.3 multiplied by 10 to the power minus 7. Okay. Part 3. Part 3 is 0 point, how many zeros? 1, 2, 3, 4, 5, 6, 7. So after the decimal point there are 7 zeros. There are 7 zeros and then 5, 3 and 4. After the first step I will count all the number of, I will find y. What is y? All the number of digits to the right hand side of the decimal point up to the first non-zero digit. So those digits are these digits up to 5. So after decimal point I have 7 zeros and then the digit 5. So y will be 8. After step 2 I will find x. What will be x? In the given number you consider the given number as a whole number, that is by ignoring the decimal point. So whole number becomes 534 and then you put a decimal point after the leftmost digit. So x becomes 5.34. And as a final step you find the standard form, which is x multiplied by 10 to the power minus y. This is equal to 5.34 multiplied by 10 to the power minus 8. Okay. Part 4 is 0.0027. So after first step I will find y. What is y? The number of digits to the right hand side of the decimal point up to the first non-zero digit. So those digits are 0, 0 and 2. So y is equal to 3. And then after step 2 I will find x. How will I find x? X will be the given number, the given small number, consider that as a whole number ignoring the decimal point. So it becomes 27. And then you put a decimal point after the leftmost digit and it becomes 2.7. Now as a third step or the final step, the standard form will be x multiplied by 10 to the power minus y, which is equal to 2.7 multiplied by 10 to the power minus 3. Okay, part 5 is 0 point, how many zeros? 1, 2, 3, 4, 5. 0.5 zeros and then 1, 6, 5. Okay. Count after step 1, count, we will find y. Count the number of digits to the right hand side of the decimal point up to the first non-zero digit. So those digits are the 5 zeros and then the 1, that is 6. After step 2, I will find x. What is x? X will be the given number, ignore the decimal point, you get the whole number, that is 165. And in the number 165, put a decimal point after the leftmost digit and it becomes 1.65. Now after the final third step, the standard form will be x multiplied by 10 to the power minus y. This is equal to 1.65 multiplied by 10 to the power minus 6. Okay. Part 6. Part 6 is 0 point, how many zeros? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. After the decimal point, there are 8 zeros. There are 8 zeros and then we have 689. Fine. After step 1, I will find y. What is y? The number of digits to the right hand side of the decimal point up to the first non-zero digit, and those digits are up to 6. So I have 8 zeros after the decimal point and then the 6, that is y is 9. Now after step 2, I will find x. What is x? X will be the given number. You consider the given number as a whole number by ignoring the decimal point. So we have 689 and then you put a decimal point after the leftmost digit, 6.89. Now as a final step, the standard form will be x multiplied by 10 to the power minus y. This is equal to 6.89 multiplied by 10 to the power minus 9. So this is the number in standard form. So that was end of problem number 5. Let's do problem number 6. Problem number 6 says 1 micron. 1 micron. I guess the symbol of micron is this. I don't know. Yeah. So 1 micron is given as 1 by 1. How many zeros? 6 zeros. Okay. 1 by this amount of meter. Express it in standard form. Express it in standard form. 1 micron. We have to basically we have to express 1 micron in standard form. So we have to express this thing in standard form. Now what is this? This is equal to 1 by, we have, this is equal to 1 by 10 to the power 6 because there are 6 zeros after 1 in the denominator. This is equal to, we know from the laws of exponents, it is a reciprocal of 10 to the power 6. So this we can write it as 10 to the power minus 6. Because we know that 1 by x to the power m, x to the power m is in exponential form. This is nothing but equal to x to the power minus n. So 1 by 10 to the power 6 is equal to 10 to the power minus 6. So the number given is 1 multiplied by 10 to the power minus 6, which is in standard form, meter. So 1 micron is equals to 1 multiplied by 10 to the power minus 6 meter in standard form. Oh, this was part 1. Problem 6 has 3 parts. Okay. Part 2. Size of a bacteria. Okay. Size of a bacteria is given as 0 point, how many zeros? 1, 2, 3, 4, 5, 6. See 0.6 zeros and then 4. This meter. Size of a bacteria is this meter. Express it in standard form. Okay. This is a very small number. So first step, y, which is the number of digits to the right side of the decimal point up to the first non-zero digit. So those digits are all the digits to the right hand side of the decimal point. So how many digits are there? There are 6 zeros and then 4. So y is 7. After step 2, we will find x. What is x? Consider the given number as a whole number by ignoring the decimal point. So it will be 4, and then put a decimal point after the leftmost digit. It will be 4 point, but usually we do not write 4 point, we write it at 4.0. Okay. Now as a final step, the standard form will be x multiplied by 10 to the power minus 1. 10 to the power minus y. This is 4.0 multiplied by 10 to the power minus 7. You can 4.0, you can write it as 4 multiplied by 10 to the power minus 7, this much meter. So this is the size of the bacteria in standard form. Okay. There is part 3. Okay. Thickness of a paper is 0.03 meter. Okay. Express it in standard form. Fine. So even though this is, you can do it very manually, let's anyway do it using the steps or algorithms we discussed. After step 1, what will I do? I will find y. What is y? The number of digits to the right hand side of the decimal point up to the first non-zero digit. So the digits will be 0 and 3, which is 2. Now after step 2, I will find x. What will be x? The given number. I will consider it as a whole number by ignoring the decimal point, which will be 3. And I will put a decimal point to the leftmost digit. So it will be 3.0. Now the final step is the standard form will be x multiplied by 10 to the power minus y. This is equal to 3.0 multiplied by 10 to the power minus 2, this much meter. So this is the size of the thickness of a paper in standard form. That was question number 6. Let's do the final problem, and the final problem has also 6 parts. Okay. Problem number 7, write each of the following numbers in usual form. Okay. Now this problem, writing a given number in standard form, usual form, is basically the concept of applying the multiplication of decimal numbers, that how well you know how to multiply a given decimal number with powers of 10. Part 1, 2.06 multiplied by 10 to the power minus 5. So these are very small numbers. We have to express in standard form. The problem number 2 was expressing a very large numbers in standard form, in the usual form. Okay. So 2.06 is 206 divided by 100, which is 10 square. We have multiplied by 10 to the power minus 5. This is equal to 206 multiplied by 10 to the power minus 5 multiplied by 10 to the power minus 2, because we have 1 by 10 square, which is equal to 1 by 10 square is equal to 10 to the power minus 2 from the laws of exponents. So this is equal to 206 multiplied by 10 to the power minus 7. Now it is all about applying your concept of how do you multiply a number, decimal number, with the powers of 10. Now if the power, not multiply, but basically this is a division, dividing a decimal number with the powers of 10. Now this is nothing but, so basically we are, when the power is negative, when the power of 10 is negative, which means you are dividing 206 by 10 to the power 7. So where will be the decimal point? So whatever the number in the numerator is, we have 206. So the decimal point is, even though there is no decimal point, 206 you can consider as 206 is nothing but 206.0. Now if you divide 206 by 10 to the power 7, the power is 7, you have to shift the decimal point 7 places to the left hand side. So 1, 2, 3, 4, 5, 6, 7. This is the way I would like to do. So this will be the final position of the decimal point, and in between all the empty spaces there will be zeros. There will be 4 zeros. So after the shifting I have 0.0000206. So this is nothing but when you divide a number, a decimal number, by some power of 10, in this case power of 10 to the power 7, you just have to shift the decimal point in the decimal number which is in the numerator to the left 7 places to the left. Since in this example it is dividing by, you are dividing by 10 to the power 7, and so when you and 206 in the decimal form is 206.0. So if you shift the decimal point to the left hand side 7 places, it becomes this number. So the given number in standard form, in usual form, is 0.0000206. This is the usual form of the given number in standard form. Okay, let's do part 2. Now for expressing a number in standard form, the usual form, the main concept that you will need to apply is multiplying a decimal number with powers of 10, multiplying and dividing decimal numbers with powers of 10. You have to be very well versed in that area, in that concept. Part 2 is 5 multiplied by 10 to the power minus 7. This is nothing but basically you are dividing 5 by 10 to the power 7. So I have to convert the number 5 which is in the numerator by shifting the decimal point. So 5 has no decimal point, but you can consider it as 5.0. If you put a decimal point, it will be 5.0. I have to shift the decimal point to the left hand side 7 places to the left hand side. So when I am shifting the decimal point to the left hand side 7 places, it will be something like 1, 2, 3, 4, 5, 6, 7. The last shift jump will be the place of the decimal point, and in between all the empty places will be filled with zeros. So how many zeros are there? 6 zeros. So this becomes 0.6 zeros, and then the 5. Then the 5. This 0 you did not write because in a decimal number all the trailing zeros are you can ignore them, they are useless. Okay, so this becomes equal to, the number in usual form is 0.6 zeros 5. Okay, part 3, 6.82 multiplied by 10 to the power minus 6. So this is nothing but you are dividing by 6.82 dividing by 10 to the power 6. So you will have to, so I have the number in the numerator is 6.82. I have to shift the decimal point to the left 6 places. So 1, 2, 3, 4, 5, 6. The last shift jump will be the place of the decimal point, and in between you fill up with all zeros. So we got the number as point, how many zeros? 5. So this is the number in usual form will be 0.50682. Let's do part 4. Part 4 is 5.673 multiplied by 10 to the power minus 4. So this is equal to 5.673 divided by 10 to the power 4. So I mean, the shifting of the decimal point that I am doing visually, quite obviously you will not do this in your exam or question paper or answer sheet. This is just for the understanding. Where will the how do we shift the decimal places to the left hand side, and if there are no digits, how do we fill those places with zeros? So we have to shift the decimal point to the left hand side by 4 places, because we are dividing by 10 to the power 4. So 1, 2, 3, 4. The last one will be the position of the decimal point, and we have 3 zeros in between. So this becomes 0.305673. So this is equal to 0.30 and 5673. This is the number in standard, is in the usual form. Okay. 5, part 5, 1.8 multiplied by 10 to the power minus 2. Now these for powers for powers of 10, I mean for powers of 10 which is very small, you can do it manually. Obviously this will be nothing but 0.018. All these in the standard form, where the power of 10 is very small, like 2 or 3, you can possibly do it manually. I hope this is right. It will be yes. So this is the number in standard in the usual form. Part 6 is 4.129 multiplied by 10 to the power minus 3. So this is 4.129 divided by 10 to the power 3. This is equal to for powers of 10 which is a little more, like 3, 4 or 5, you can if you are not very sure, you can do it visually. So I have to shift the decimal point to the left hand side by 3 places. So 1, 2, 3. This is the decimal point, 0, 0. So I have 0.004129. So this is equal to 0.004129. So this is the number in usual form. Okay, so this brings an end in solving the problems of exercise 2b, which was based on the numbers in standard form and how to express very large numbers and very small numbers in the standard form using the exponential notation. And also to apply the concepts understanding, we solved the problems of exercise 2b. I hope this video was beneficial. If it is, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So in the next video, I think there is an objective questions. Let me check. This is chapter exponents. Okay. I think this was exercise rational number. Okay, exponents. This was exercise 2b. Then we have exercise 2c, which is objective questions, and then we have test paper 2. Okay, so the next video will be on solving the MCQ, that is exercise 2c, and after that I will solve the test paper 2. That will bring an end to in discussing the concept of exponents from the book and solving the problems of the book. But after that I will prepare two sample test paper, number 1 and number 2, which I will solve. Those will be MCQ questions, 15 MCQ questions, and ideally you should be able to solve them in 45 minutes. So anyway, stay tuned for those upcoming videos. Thanks for watching, and until the next video, take care and bye.